Today we'll cover three topics: what the solar wind is, how the magnetosphere works, and why this matters for life, technology, and Mars missions. The main idea: the Earth's magnetic field creates a protective bubble that deflects charged particles. Protection is important in three areas: health and DNA, satellite electronics reliability, and astronaut safety. Without shielding, radiation damages cells and simultaneously breaks technological systems. Let's fix the definitions. Solar wind is a stream of charged particles from the Sun. A charged particle is a proton or electron. The magnetosphere is a region where Earth's magnetic field dominates. A geomagnetic storm is a strong disturbance of the system during high solar activity. The Sun constantly ejects plasma, a stream of particles that travel through interplanetary space and reaches Earth. This is not a rare event, but a background cosmic wind. Since the particles are charged, the magnetic field changes their trajectories. They don't fly straight to the surface, but are deflected and flow around the protected region. The magnetosphere works as a shield, redirecting the flow. The aurora is not magic, but the result of some particles being directed toward the poles and colliding with atoms in the upper atmosphere. Excited atoms emit light. Oxygen gives green and red. Nitrogen gives bluish shades. During geomagnetic storms, the change in magnetic field induces currents in long conductors, power lines, pipelines, cables. This leads to overloads, failures in power grids, and malfunctions and damage to satellite systems. In 1859, the Carrington event became one of the strongest recorded storms. Telegraph system failed. Auroras were observed far to the south, and induced currents even caused fires. Today, with our dependence on electronics, the economic impact would be much more serious. Earth is protected by a global magnetic field, while Mars has no such shield. Therefore, the solar wind more strongly blows away the atmosphere, and the radiation load on the surface is higher. This is a key problem for long-term life and human flights. One main idea: the magnetosphere deflects charged particles. Therefore, the atmosphere is better preserved, less radiation reaches the surface, and our technologies, from GPS to power grids, work more reliably. Let's check understanding. If the field weakens, what will increase the most? The correct logic: less deflection of particles leads to more penetration, leads to radiation at the surface will increase. Option B. Auroras may change, but the main risk is precisely the increase in radiation load. Thank you.